Hello dear learners, in this video we will start with the practice session for the biostats, and I will be discussing certain practice questions which will be covering different topics of the syllabus. So let us come to the first question and let us try to solve it. The question says that a fisheries biologist studied the growth of juvenile catfish in a freshwater tank over a period of 8 weeks. So he was actually studying the growth of the catfish for over 8 weeks. The average body length of the fish was recorded weekly as follows. Now from here we can conclude that as the weeks passed by, the body length was increasing continuously. So first of all, we need to create a scatter diagram for the data. How do we create a scatter diagram? First of all, we take the x-axis, then we have to draw the y-axis, and then here we can plot for, let's say, weeks. So suppose I start from 0, then 1, then 2, 3, 4, 5, 6, like that way. It can even extend to 8. And here I will be plotting the length of body in centimeter. Length in centimeter. And then whatever, for example, let's say it is 5 centimeter, 10 centimeter, 15 centimeter, and for the first week this is supposedly 6, so I will plot it here. The next one can be coming here somewhere, it can be coming here, then here, but eventually it has to increase only. So that is a positive correlation between the week and the length, body length in centimeter. The next question is that we have to compute the linear regression equation which relates the fish length y to the time x. So we have to derive this equation. And how do we do that? So we know that whatever is the dependent variable, so dependent variable will be equal to a. A is what? It is the intercept of the graph, plus b. This b is the regression coefficient, multiplied by the independent variable. So the independent variable here is this week, that is, let us assume it to be x, and here it is y, which is the dependent variable. Why? Because week is not depending upon the body size, but body size is definitely depending upon the week. So our equation will be that dependent variable, that is y, will be equal to a plus b multiplied by x. Now this is the equation which we have to derive out. But for this equation to be derived, first of all we have to compute b, we have to also compute a. After that only we can reach to this equation. So how do we compute b? For calculating this b, whatever is the variable which is independent, on that basis only we will be computing the value of this regression coefficient. So suppose if the x variable is independent, so we'll write byx. If y variable was independent, then we should have written bxy. But since here we know that x is independent, means the number of weeks are independent, so here we'll be writing byx, and what the formula would be, it would be equal to summation of x minus x bar, that is the mean, multiplied by y minus y bar. So whatever the product comes, its entire summation upon whatever the independent variable is, the summation of the difference, the squared difference between the actual value and the mean. So this one. So how do we calculate it? So I'll be just giving you the brief idea that how can you be calculating this, all the values. So at one place you'll write x. The values of x are 1, 2, 3, 4, 5, 6, 7 and 8. Then you can easily calculate the mean of x. It is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 divided by 8. Okay, let me do it on this part. Yes, so mean of x we have to calculate. So here I can be writing x. So 1, 2, 3, 4, 5, 6, 7, 8, and then we can say whatever the mean of x comes, we'll be writing here. So it can be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 divided by 8. Now we have to individually calculate the difference between that particular value of x and the mean of x. So whatever the entire values come, we will be writing those values here. Then we have to do the square of this difference. Whatever the squared values come, you will be writing here. Okay, then whatever the final values are, you have to again summate all of them. so that you can derive out this thing. After that, you will be doing the same thing for y. So for y, what will I be doing? I'll be first of all noting all the values of y. Then afterwards, I will be calculating the values for y minus y bar. And then you know how to calculate the mean. So it will be your total values whatever upon n. Now here I have to make one more column which will give the product of these two things. And whatever the values come, we have to finally summate it. Now we are only interested with the two values, that is we are interested with, one is that we are interested with this value and we are interested with this value. Now we have to only work upon them. So now if we need to calculate the b yx, it will be equal to what? So it will be equal to x minus x bar, the product of this two, means you have to, as it is, copy paste this value upon the summation of x minus x bar and its square. So whatever the value comes will be the value of b. The value of b, if you will calculate, will come out to be 5.14 approximately. Once you have calculated b, now you need to calculate a. For calculating a, again there is one of the equations and the formula. Whatever is the dependent variable will come first, so it will be equal to y, the mean of y, equal to a plus b multiplied by the mean of x. So the mean of y you already know, the mean of x you have already known, and b also you have calculated. So you have to just solve for a, that will be equal to mean of y minus b multiplied by mean of x. So a comes out to be 0.37. Once the two things have been found out, now you can create your equation. Your equation is dependent variable is equals to a plus b multiplied by the independent variable. Now they have asked you to calculate for the 10th week, means you are considering this to be 10. You know the value of b is 5.14. You also know the value of a, whatever you have calculated, that is 0.37. You can simply calculate that what would be the length of that particular fish or the group of fishes on the 10th week. So this is how you will be solving this question. Moving on to the next question now. The next question says that a plant physiologist investigated the effect of newly synthesized growth hormone on the leaf area development in the young sunflower plants. Now there were 10 plants initially and you have divided them into two groups. Means you are performing one experiment on one group and then you are performing one experiment on the another group. And you have taken 10 plants. So n is equals to 10 and then you have taken two groups, not a single group. So from n equal to 10, you know that whenever the value of n is less than 30, you will apply the t-test. And whenever it is two different groups on which you are doing the experimentation, then it becomes your unpaired t-test. So you have to simply solve this with the unpaired t-test formulas. So how do you solve that? Let us assume it to be x1 and let us assume it to be x2. So now we will be simply putting the values. Here we will write first x1, the values of x1. Then we will be also be calculating whatever the protocols are. We have to calculate like this way now. And then we have to also calculate one column where we are squaring this difference. Right. You know how to calculate mean simply. Same thing we will be doing with the another set also, that is for, this is also 1 and 1 only. Now for the x2, you will be first of all noting down the values, then x2 minus x2 bar, and then x2 minus x2 bar and its square. Once you calculate all of this, now you have to summate it. Here your one value will be coming, that is summation of x1 minus x1 bar and its square, and here your value will be coming summation of summation of x2 minus x2 bar and its square. Now from this you will be calculating the standard deviation. The formula of standard deviation for the unpaired t-test comes out to be root of summation x1 minus x1 bar and its square plus summation x2 minus x2 bar and its square upon n1 plus n2 minus 2. Once you solve the formula for standard deviation, now you know what needs to be done. After this, you have to calculate standard error from the standard deviation. So standard error comes out to be standard deviation multiplied by root of 1 upon n1 plus 1 upon n2. You know the value of n1 is also 5, value of n2 is also 5. And here also it will be equal to 5 plus 5 minus 2, that is 8. And this you can calculate by yourself, and then you can also calculate the standard error by yourself. Once you are done with the standard error, now you have to simply put the formula for the t-test. The formula for the t-test is the sample mean, the first sample mean minus the second sample mean upon the standard error. Now first sample mean you have already calculated, here it would be. Second sample mean also you have calculated. Upon standard error also you have calculated. So whatever the answer comes out to be, it will be coming approximately 4.42 after calculations. Now you have to check the value of t from the table also. They have told that you have to test at 5% level of significance, means you have to test the value for t at 0.05, and then you have to also see the degree of freedom. So here the degree of freedom is n1 plus n2 minus 2. So it will be 5 plus 5 minus 2, it will be 8. So at degree of freedom 8 and at the level of significance 5%, you have to find the value of t from the table, from the t table, and it comes out to be 9.42. Okay, wait. It's not 9.42. Uh, it is 2.36, 306 approximately. And this is not 9.4, this is not 4.42, it's actually 9.42. Yes. So whatever you have calculated the value, it comes out to be 9.42, and whatever the table is giving the value, it is 2.306. Now from here you can easily say that whatever your calculated value was, it is greater than this value from the table. In this condition, you will always reject the null hypothesis. Now that is also a mistake which we did, that is we did not write at very first the null and the alternate hypothesis. Whatever the question asks, examine whether the hormone treatment significantly altered the leaf area. So we'll write it as the null, as the alternate hypothesis, that yes, the hormone treatment affected the leaf area index, and here we will write that does not affect. Now your calculated t value was 9.42. The observed t value at degree of freedom 8 and 0.05 level of significance came out to be 2.306. Now since your calculated value was greater than 2.306, you say null hypothesis is rejected. That means there is definitely the effect of hormone treatment on the leaf area index. So that is how you will solve this question, where the clear hints are given that it is unpaired t-test. Moving on to the next question. The average hemoglobin concentration in the healthy population. Now you have to see the population. They have mentioned it as population. So the hemoglobin concentration in that population comes out to be how much? It is 13.5 gram per dl. So means population mean here is given as 13.5 gram per dl. That is deciliter. A laboratory technician measured the hemoglobin level in 12 randomly selected individuals. Means the size of sample is 12.